This is lesson 2-6, theoretical and experimental probability. This lesson has lots of vocabulary words, so be sure you pay attention and make sure you understand these. You may need to play them again to make sure you understand. Probability is the likelihood that an event will occur. For example, if I'm going to shoot a basketball, let's say I'm going to shoot a free throw, only one of two things will happen. I will either make the free throw or I will miss the free throw. There could be 1,000 things as to why I missed the free throw, but that doesn't matter. Only one or two outcomes can happen. I will make the free throw or I will miss the free throw. Probability is the likelihood that it will occur. The outcome is the result of a single trial, like rolling a die. If I was to roll one number cube, the result would be whatever number I happen to roll. That's considered to be an outcome. The sample space is all the possible outcomes of an event. For example, let's take that number cube. If I have a number cube, the possible outcomes are 1, 2, 3, 4, 5, and 6. So that becomes what we call the sample space. An event is any outcome or group of outcomes. For example, if I wanted to figure out what is the probability of rolling a 3 on my number cube, the event would be rolling a 3. It occurs one time out of 6 times. So that probability would be 1 to 6. Theoretical probability is the ratio of the number of favorable outcomes to the number of possible outcomes if all outcomes have the same chance of happening, like flipping a coin. As long as you don't have a two-headed coin and it doesn't land on an edge, theoretical probability says that the probability of flipping a head is 1 out of 2 because there's one favorable outcome of heads out of 2 possible outcomes, heads or tails. It's normally written as a fraction and normally written in lowest terms. So if I have the probability of a head in flipping the coin, I can get 1 head out of 2 possible outcomes. So its probability is 1/2. The complement of an event is all the outcomes not in the event. For example, let's go back to our number cube. The probability of rolling a 3 is 1 out of 6. There are 6 numbers on a number cube. Only one of them is a 3, so the probability of rolling a 3 is 1/6. The probability of not rolling a 3 is 5 out of 6 because there are 5 numbers on that number cube that are not 3s. So the complement of rolling a 3 is not rolling a 3. Now, odds is a little difficult sometimes for people to understand. They get it very confused with probability. Odds is the likelihood of an event by comparing favorable to non-favorable. Probability does favorable to possible. If you look up here, probability does all of my favorable events out of all of my possible events, where odds does all of my favorable events out of all of my unfavorable events. Difference. The probability of rolling a head is 1 out of 2 because there is one favorable outcome, one head, out of 2 possible outcomes, head or tail. The odds of rolling a head is 1 to 1 because there's one favorable event, a head, and one unfavorable event, a tail. That's the difference between probability and odds. Experimental probability is probability based on data collected from repeated trials. For example, theoretically, we should flip a head on a coin that has a head and a tail half the time. However, if you only flip that coin twice, the chances that you'll get a head one time and a tail the other time is not as likely because that's called experimental probability. That's because you experimented to see if that did occur. The greater number of trials you have, the closer your experimental probability will come to your theoretical probability. If I flip a coin 100 times, theoretical probability says that I should flip a head 50 times. If I actually do flip it 100 times, I may or may not flip it a head 50 times. I may get a head 42 times and a tail 58 times. How do we use probability? Let's take a number cube. A number cube is a regular dice that you roll like when you're playing Monopoly. You're using 1 instead of 2. It has the following numbers on it: 1, 2, 3, 4, 5, and 6. So that's considered to be its sample space. If I wanted to roll an odd number, that would be the event. So rolling an odd number says that's the event that I want to try. My sample space is that if I roll a dice, I come up with 1, 2, 3, 4, 5, and 6. That's the sample space. That's all the possible outcomes when I roll one die. My favorable outcomes, or those outcomes as to what I want, which would be odd numbers. The odd numbers are 1, 3, and 5. So my favorable outcomes are 1, 3, and 5. My event is rolling an odd number. My sample space are all the possible numbers I can roll on the die, and my favorable outcomes are the outcomes of what I want, which is rolling an odd number. Hopefully that helps you understand sample space, event, and outcomes a little bit better. Now let's take a look at something. Let's say we have a glass jar containing 6 red, 5 green, 8 blue, and 3 yellow marbles. If a single marble is chosen at random, and you can't look in the jar and see it if you're blindfolded, what is the probability of choosing a red marble, a green marble, a blue marble, or a yellow marble? Okay, all of these probabilities are separate. So we're looking for probability of red, probability of green, probability of blue, and probability of yellow, all separate. Before we can start figuring out those probabilities, we have to figure out our sample space, which means we need to add these up. If we have 8 red, and we have 5 green, that's 6 red, excuse me, 6 red, 5 green, 8 blue, and 3 yellow. If we add that up, 6 and 5 is 11, plus 8 is 19, plus 3 is 22. We have 22 total marbles in our jar. And we have 22 total marbles in our jar. Now, to figure out the probability of that, we're simply going to look at our probability says the number of favorable versus the number of total. So we want red versus total. Well, how many marbles are red? Well, if you look over here, there are, 6 red marbles. So 6 marbles are red out of a total of 22 marbles. Now, of course, we reduce this. 6 over 22 reduces to 3 over 11. So the probability of pulling out a red marble is 3/11. The probability of pulling out a green marble is going to be green over total. Now, how many green marbles are there? There are 5 green marbles. Out of how many total marbles are there? There are 22 total marbles. It doesn't reduce, so the probability of pulling out a green marble is 5 over 22. If we look for probability of a blue marble, that would be blue out of total. How many marbles are blue? There are 8 marbles that are blue. How many marbles total? 22 marbles. If we reduce this, we can divide it by 2, and we get 4 over 11. And last but not least, what's the probability of pulling a yellow marble? That would be yellow over total. There are 3 marbles that are yellow over 22 total marbles. That does not reduce, so it stays as 3 over 22. Now let's look at the difference between probability and odds. Same type of problem. Okay? In fact, the exact same problem, but now we're going to look at odds. So I'm going to rewrite my totals down here so that I know there are 6 red, there are 5 green, there are 8 blue, and there are 3 yellow. Odds of finding all of these. What is the odds of choosing a red? That would be red over not red. Well, how many marbles are red? Well, there are 6 marbles that are red. How many marbles are not red? Well, all the rest of these are not red. 8 and 8 is 16. So 16 marbles are not red. So 6 out of 16 tells me that I can reduce that. If I divide it by 2, I get 3 out of 8, or 3 to 8. Normally, odds are written with the word 2. It's just the way they do it. I do not know why, but it's just every time I see odds, they're always written as 3 to 8. Right? If I was looking at the odds of choosing a green, I want green over not green. Well, how many green marbles are there? There are 5 marbles that are green. How many marbles aren't green? Well, 6 plus 8 plus 3. 6 and 3 is 9. 9 plus 8 is 17, so it's 5 out of 17. So 5 to 17. And now I want the odds of choosing a blue. It would be blue over not blue. Well, how many marbles are blue? There are 8 marbles that are blue. How many marbles are not blue? Well, 5 and 3 and 6. 6 and 5 is 11. 11 and 3 is 14. Again, I can reduce this by half. This becomes 4 to 7. And last but not least, we need to figure out how many marbles, what's the odds of getting a yellow. So that would be yellow over not yellow. Marbles that are yellow, 3. Marbles that are not yellow, since I know there's 22, what's 22 minus 3? 19. So there are 19 marbles that are not yellow. So this would be 3 to 19. That's the difference between probability and odds. Let's look at theoretical and experimental probability a different way. In a game, you can choose one of 5 envelopes. One envelope contains $100, the rest nothing. Find the probability of not choosing the $100. This is the complement of an event. Okay? The probability of choosing the 100 would be there's one way of choosing the 100 out of 5 total ways. So it's 1/5. The probability of not choosing the 100 is what we call the complement of this event right here. There are 4 ways I can not choose the $100 out of 5 total ways. When you add an event and its complement, they should equal 1, which in this case, 1/5 plus 4/5 does indeed equal 1. An event plus its complement equals 1. All right, let's get into some experimental probability. Quality control inspected 500 belts at random. They found no defects in 485 of these belts. What is the probability that a belt selected at random will pass quality control? So in other words, it'll be a good belt. So the first thing we're going to do is we need the probability of no defects. Okay. If we look at it, they found no defects in 485 out of 500 belts. So that would be no defects out of total. If we look at that, we're looking at going, goodness gracious, we can reduce that, can't we? Okay. If I divide it by 5, 485 divided by 5 is 97. 500 divided by 5 is 100. So what is the probability that a belt selected at random will pass quality control? It's 97 out of 100, or you can even put that as a percentage. 97% of the time, belts will pass quality control. Let's go one step further. Why do we do this? Because if they pass quality control 97% of the time, and if they made 6,258 belts, how many belts are likely to have no defects? Out of 6,258 belts, how many are going to be perfectly good and we can ship them out? Well, that would be 97% of 6,258, because the probability of no defects is 97%. So if we took 6,258 and multiplied it by the percentage, because that's easier than multiplying it by the fraction, we can figure out how many belts will pass quality control. If we multiply that out, you'll get 6,070.26. I can't sell 0.26 hundredths of a belt. There's no way I can sell 26 hundredths of a belt. So you'll simplify this, so it's approximately 6,070 belts will pass quality control. That's the difference between theoretical and experimental. Theoretical is what will happen in theory. Experimental is actually what happens.